Hello everybody and welcome back to more of the 2012 Hypatia contest, and we're on question number 3 in this video. So we've got 3 parts here, A with a light bulb, and now we've got 2 parts that are written. So we'll just dive in here. Looks like we, just based on the pictures, we've got parabolas to deal with, and that's okay. That's grade 10 material in most places. So, question 3A. Points 1/2, 1/4, and n squared lie on the parabola with equation y equals x squared. Okay, that makes sense. A half squared is a quarter. Determine the value of n such that MON is 90 degrees. Alrighty. So I see sort of 2 approaches. The first one, we see that MON, that's 3 points, we could form a triangle and we'd need it to be right angled. So we could do things like calculate the distance from O to M. That's going to be an actual number we can work out. O to N, that's going to be a different distance, but we could still figure out that length. Then we'd have the 2 legs of the triangle. Now, calculating the distance between M and N is still possible. It'll all be in terms of N. And, then because it's a right angle triangle, OM squared plus ON squared should be MN squared. We get a giant equation in terms of N, and we would just need to solve for that. Okay? Because if you have 3 sides of the triangle and they satisfy the Pythagorean relationship, a squared plus b squared equals c squared, then they must have a right angle. So that's certainly one way we could approach this one. But the reason I don't want to do that is because we're going to get a very big formula in n. I don't think it's going to be particularly wieldy. So what I'm going to do instead is I'm just going to rely on lines and slopes of lines. So what we've got here, they don't even complete the triangle for us. So that's another hint that maybe they don't want us to do triangles. But we've got MO and ON, and I can figure out the slopes there pretty quickly. It'll still be in terms of n, but it will be at best an n squared, whereas I think the other way will have n to the 4th in there a couple times. So we want to avoid things like that. Quadratics, very easy to solve. Let's not make more work for ourselves. So, ON is perpendicular to OM if their slopes are, we call it negative reciprocals. Alright, well, what's the slope of OM? It's rise, so we go up by 4, or up by a quarter, a fourth, minus 0, so that's the rise, that's how far we go up, and then over run, so this is a quarter, over a half, bring the 2 to the top, so we're going to have 1/2. So we want the slope of ON to be equal to -1 over this 1/2, or -2. What's the slope of ON? Well, again, rise over run. We get n squared over n, or n, so n is going to be -2. Now, did they just ask for n, or do they want the coordinates? What did they want? Determine the value of n so that MON gives us 90 degrees. Well, there we go. N is going to be -2. Okay? I'm not saying you couldn't do it by figuring out distances, but just for a moment, let's just sort of off to the side. We'll figure out the distance between M and N. It'll be in terms of N, but we would need this if we were going to go the Pythagorean triangle route. So distance between 2 points, you take the difference in their x-coordinates, square that, and then add the difference in their y-coordinates, and square that. You can already see this is not going to be the most pleasant thing. Square root, so we'll have n squared minus n plus 1/4 plus n to the 4th minus be 2 times that, so a half n squared plus, and then 1/16. Now, fortunately, when you do the Pythagorean triangle stuff, this distance will get squared, so the square root sign will go away. But you'll have an n to the 4th and not a very friendly quartic in terms of n. So that's probably the best thing that I can say about don't do it with the distances. It's probably possible, but the slope, it was so quick and slick. Okay? And you don't want to make a light bulb question harder. We'll probably have to use the distance formula later on, maybe, because it looks like we got some other right angles, so maybe right angle triangles. I mean, PQR right there, that's a right angle triangle. That certainly suggests it, but we'll see. Maybe we just keep using slopes. I don't know. Let's read these questions. So B we need to write. Points 2, 4, and b squared are the endpoints of a chord of the parabola with equation y equals x squared. Are we using y equals x squared? Yeah, we're using it every time. Okay. Determine the value of b so that AOB is 90 degrees. So I really think the same sort of technique will work. It's just the slope of AB will be a little weirder. But yeah. And it's going to be basically the exact same write-up. So AB is perpendicular to OB if their slopes are negative reciprocals. So let's figure out, we're going to have to get the slope of both AB and OB. It's all going to be in terms of B. So the slope of OB is probably easiest. It would be B squared minus 0 over B minus 0. The slope is just going to be B. Not bad. Now the slope of AB, it's the rise, and it was 2, 4, right? Yeah, 2, 4 is A. So we rise 4 from B squared over 2 minus B. Now we can factor the top into 2 minus B, 2 plus B. So this is a difference of squares formula. And so the slope of AB is just going to be 2 plus B. Okay, so moving on to the next page, we need these guys to be negative reciprocals. We need 2 minus B to be negative 1 over B. All right. So let's multiply through by B. So 2b minus b squared is equal to negative 1, or rather b squared minus 2b minus 1 equals 0. Yeah. So we can't complete a square here. Or, sorry, we can complete a square. I would have thought there'd be only one solution for B. I mean, I guess we got a B squared there, so maybe, but... And you know what it is? I think it's 2 plus B, not 2 minus B. That's where I goofed. Yeah. So I'm going to say, based on the picture, from O to A, that's going to be the hypotenuse of the triangle heading out here and a triangle down here. So I would have thought, I guess, maybe my intuition was wrong. Anyway, I did clarify everything, or did clean everything up, and I think we will just get one solution here. So it's 2b plus b squared, and then we'll get b squared plus 2b plus 1 equals 0, and then this is b plus 1 all squared. You can recognize that, or you can do some factoring, whatever you want to. So that tells me b is negative 1. Now, did we just want b, or did we want the coordinate? Determine the value of b. Yeah, negative 1 and 1 will do. All right. So maybe put a little box around that. It's not a light bulb question, so they don't have a box provided for the answer, but putting a box around things helps the markers, certainly. And now the question that actually had the triangle. So, right angle triangle PQR is inscribed in the parabola, the same parabola we've been using the whole time. Points P, Q, and R have coordinates P squared, Q squared, R squared. So they're not giving us anything. They gave us some points earlier on. And we don't even get the origin this time. If p, q, and r are integers, show that 2q plus p plus r is equal to 0. Okay, I'm guessing it's the q there because of the q is the one with the right angle. That's why he gets doubled. Why would we need the condition that they're integers? I don't know. Now they gave me a triangle, and I said earlier maybe we should be using distances. The triangle makes me suspect maybe Pythagoras, but what does RP actually help us work with? I mean, all I need is RQ and QP to be right angled, so I still could probably do slopes, but maybe that'll only give me one equation in 3 unknowns, so I don't know. But I'll try it with the slopes just because that's been working for me. And they tend to structure these questions so you have sort of a common theme. And working with slopes, getting the negative reciprocals of one slope being equal to another slope, seems to be working. So that's what I'm going to try first. If that doesn't work, I've got time. I can try my Pythagorean triangle distance formula method. But I dismissed that in A part because it was too complicated. And now we've got 3 unknowns. It should be even more complicated. But we'll hold that in reserve in case we need to work out more information. But I know that PQ is perpendicular to RQ, so slopes are negative reciprocals. Before, we've been using the fact that if you have negative reciprocal slopes, you get 90 degrees. Now we've got 90 degrees, so we know the slopes are negative reciprocals. So the slope of PQ, so that's P squared minus Q squared over P minus Q. Well, hey, that formula right there, we can factor the top, and then it should be negative 1 over r squared minus q squared over r minus q. P minus q and p plus q. This is a difference of squares formula. If you haven't seen it, there it is. And I suppose I can write this upside down. Negative this, r minus q, r plus q. Cancels, 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 cancels. So, I don't know whether or not I should say something about P has to not be equal to Q and R has to not be equal to Q. If P and Q are equal, then we've got 2 points in the parabola that somehow lie above each other, and that never happens. I don't know whether or not I need to say something about that. You can if you want to. It would just be a quick sentence. But so P plus Q is negative 1 over R plus Q. So, could I solve for R in terms of Q, or maybe solve for Q in terms of R and P, and then show that P plus R has got to be equal to negative 2Q, and then that would show the relationship, wouldn't it? If I wanted to solve for Q, I'm a little stuck because he's in 2 places. And if I wanted to solve for R, I'm a little stuck because he's not in the most accessible. So let's solve for P. P is negative 1 over R plus Q minus Q. I can change that to negative 1 minus Q R plus Q all over R plus Q. So there's P right there. And we have to use the fact that they're integers. I'm not seeing where. Let's change it to RP plus PQ is equal to negative 1 minus Q R plus Q. So that's minus QR minus Q squared. we have a quadratic in terms of q, but then we have an r and a p. So, and I'm not getting to a point where I need to use integers. So maybe solving for p wasn't the best way. If I wanted to solve for q, I guess I'd have to multiply through first. That's not particularly going to help me. And then expand this out. So that'd be RP, wait a minute. -1 over here. Okay, let's stop and think this through. If P, Q, and R have to be integers, then P plus Q and R plus Q have to be integers. And so, but then the -1 is a product of integers. So this one's got to be 1 and this one's got to be -1, or this one's got to be -1 and this one's got to be 1, and that's really the only possibilities if they're integers, whereas that would fail if they were allowed to be reals. Because remember, they did give us this information. If their integers show that this has got to be equal to 0, they wouldn't just idly give that to us. But I would have thought that this relationship should hold with any right angle. Anyway, it doesn't matter whether or not it holds with any right angle. Clearly, we need them to be integers because they told us that. That's free information. I say we go with it. Let's use it. So I would say something like P, Q, R integers. So P plus Q, Q plus R are integers. So we have two possibilities. I don't think there's a quicker way to write this. P plus Q is -1. Q plus R is 1. So either way, I guess what we have here is P plus Q is -Q plus R. And so that is a relationship. Does that that rearranges to so since P plus Q is -Q plus R, so -Q minus R, rearranging P plus 2Q plus R equals 0. Which is what we wanted. Okay, well, I wonder how many ways you could have gotten this if you didn't happen to just rearrange it like that. I also, as I say, I suspect maybe this is true even if they're not integers. Seems like a very silly thing to be true just because they're integers. And maybe, just maybe, if you do the distance formulas and the squaring and everything, you can get 2Q plus R plus P is equal to 0. But, I don't know, stuff I don't need to worry about. It's theory, and it's beyond the questions. I wouldn't worry about it on a contest. I've written up my solutions. I've explained their integers, so that gives me these possibilities, and it rearranges to get the solution they asked for. So that's question 3. And if you want, you can join me for question 4. I think just for a moment, I want to see how the distance formula works out, and whether or not I can show 2Q plus P plus R is equal to 0, period. So if you're just here for the Hypatias, I'll see you in the next video for question 4. That's it. I'm just gonna explore, because I think this relationship is independent of the integers, and I want to see if that's true. Okay. So I'll even fade out for a second for those of you who like that sort of thing. And now we're back. All right. We're going back, and we're gonna do this a different way. Fresh sheet of paper. Okay. P, R is R and R squared. Q q and q squared. I don't know if this is going to work out. And maybe in 5 minutes I'll have to say, nope, this just isn't working. Okay, so we've got these points, and we claim we've got a right angle. I'm going to avoid the slope because I want to say, let this be A, B, and C. So a squared plus b squared is equal to c squared. But, and I'm going to go a little faster because I'm not explaining this, I'm just going to explore. A squared is the difference in x coordinates and y coordinates squared and added together. So q minus r squared plus q squared minus r squared squared. That's A. And then B is the same thing but with p's. Q squared minus p squared squared. And that's got to be equal to c squared. Well, I'm going to actually rearrange this to be minus c squared equals 0. So minus, and then what's c squared? Well, it's p minus r squared, and then p squared minus r squared squared. Okay, so difference of squares, we could definitely factor out a q minus r squared. I think I'm just going to take a look at the whole thing all together. So q squared squared. So these are the fourth powers that I was dreading earlier, and they might be what causes me to quit this in a moment. Q squared minus 2pq plus p squared plus q to the fourth minus 2p squared q squared plus p to the fourth minus p squared plus 2pr minus r squared minus p to the fourth plus 2p squared r squared minus r to the fourth. Alright, and these guys have to be equal to 0. Okay, what things cancel? R to the fourth and r to the fourth cancel, p to the fourth and p to the fourth cancel, r squared and r squared cancel, p squared and p squared cancel. I don't have a 2pr sitting around, and I don't have a 2p squared r squared sitting around. But what have we got? We got 2q to the fourth, 2q squared, and then minus 2, and it's pq plus qr minus pr, minus 2, and it's p squared q squared plus q squared r squared minus p squared r squared has got to be equal to 0. Okie dokie. So I was hoping that somewhere in here we'd sort of be able to factor out a 2q plus p plus r. But I'm not seeing anywhere that might happen. One thing I can do, I can divide by 2. I'm going to have to bounce back and forth here for a moment, but q to the fourth plus q squared minus is pq plus qr minus pr. It was a minus, right? Yeah, minuses again. So p squared q squared plus q squared r squared minus p squared r squared. Now these, I think this one and this one are related, and this one might be related. So let me group them together. So minus p squared q squared minus q squared r squared plus p squared r squared. I think this is q squared minus p squared times q squared minus r squared. Get the q to the fourth. Yeah, it is. And this one, I think, is going to be, it's q squared minus pq minus qr plus pr. This one is going to be q minus p, q minus r. So these guys have to be equal to 0. And I have to add to be equal to 0. And we get q minus p, q minus r here. And what's left? Q plus p, q plus r. And then we get, so put that all in brackets, then plus 1 is equal to 0. So these guys can't, so q is not equal to p, q is not equal to r. So therefore, q plus p times q plus r plus 1 is equal to 0. And I think we're right back to the original relationship, that the product of these two is equal to -1. Not satisfying, but yeah, there it is. So since I got back to the same place I did, at least this shows that the distance formulas would certainly work. I know I went a little quicker than some of you might have been expecting, but I wasn't trying to teach how to do a question there. I was just satisfying my own and possibly your curiosity if you're still watching. And yeah, since I got back to the same spot, I don't have any new information. So we do have to rely on p, q, and r being integers. Right? Yeah. So I just want to get a counterexample. Shouldn't be hard to make a counterexample. I don't know. Let's let q equal 0. Then p be 1, and actually q be -1. So we wouldn't be able to rely on integer counterexample. So how about a half? And negative. Nope, that's going to do it too. So let's not have q be whatever it is. Let's set so let's let q be 1, and so p is going to be a half, and r is going to be -1/3. Right? Because then 2q is not equal, so 2q plus p plus r equals 0. That definitely fails. And yet we do have 3/2 here and 2/3 here. Oh, it needs to be negative, so 4. So 4/3 1/2, 2 times is 1, so 2.5 is not the same as 1.33, so it still works. We need it to be 5. 5, my point is still valid, and those become -1. Okay, so we actually do need integer, which is kind of nifty, but yeah. And the distance formula would have still all worked out. Okay, so we're going to move right along to question number 4. I'm sure most people who are watching have already joined me there. But have yourselves a wonderful day, and thanks for sticking around. It shows you're mathematically curious.